Hello everyone, I'm Jamie. Welcome to another session of Vista Export Services. In this session, I'll be taking you through the amazing step-by-step process of creating verified views for planning applications. So without further ado, let's start by opening a typical document depicting some of the proposed views by the client. As you can see, this is an example of the initial document an architect or developer would normally send to 3D visualization specialists for a quotation. You should also receive a 3D model block of the proposed building seen highlighted in a drawing map. Also, the proposed 3D building should come with its drawing coordinates of the ground level and the height on site. Depending on how tall the proposed building is, the initial proposed views will include distant views as well as the standard close-up ones as seen here. Verified views are a crucial part of a series of documents an architect or a developer needs to submit to planning authorities for permission to build, extend, or simply change the facade of any proposed building. Verified views will provide the planning authorities with an accurate visual representation of the proposed building from the proposed views. To create the verified views, there are a series of steps one has to take in accordance to the verified views methodology. Also, by law, your verified views methodology needs to be documented and included in a mandatory documentation for the planning application. I will include the documentation guidelines and the portal links for this project. It's worth noting that the initial proposed views might change depending on what's being seen. Therefore, it's important to plan the shots carefully before going to the physical site. To start, once you receive the preliminary proposed views in this format, simply go to Google Maps and type the street name of one of the views. For one of the projects I'd worked on years ago, the name of the street was Newton Butts. So on Google Maps, I've simply typed in Newton Butts and zoomed in into the area. Click on a satellite thumbnail to see the satellite photography. Assuming this was one of the proposed views, simply click, drag, and drop this yellow figure icon onto the desired area of the satellite photography. Once dropped, you can quickly pan and zoom around the location using the mouse and scroll wheel. This quick exercise often provides a quick preview of the proposed views. Ultimately, for a more accurate preview, you'll require a 3D context model of the location with a proposed 3D building in it to see the real visual impact of the proposed building from each of the proposed camera views. To acquire the 3D context model, simply visit a website called zMapping. This website provides accurate 3D context models of most areas in the UK. If you happen to be based outside the UK, simply contact me to provide you with names of other companies that provide 3D context models of other parts of the world. Once in zMapping website, to get the context model of a particular area, simply click on Get a Quote button first. In the Find Location section, simply type in the desired area. As mentioned earlier, as an example, we are going to the Newton Butts area. As you can see, the area was automatically found. Zoom into the desired area. To begin plotting the desired area for your context model, simply click on Add Polygon button. Choose the type of polygon from the drop-down list. For this exercise, let's choose the freehand type. Assuming you already know the area you want, start by pressing on a click here to start plotting, and begin clicking 3 main points to close it. Following that, you can edit the area by adding more vertices and editing the vertices. You can always click on areas where you see the cursor. Once added, the plotted area might look a bit wonky. Simply hover over it. Once you see the mouse index finger side, you can click and move the vertices to edit the plotted area. Once satisfied, simply click on the Request Quote button. In the Details section, you need to enter your name, company, email, and the remarks. In the Remarks section, you can emphasize things such as the level of detail you want the 3D model to be, the file formats required, and etc. And click the Get Quote button. You should receive a quotation reply shortly after and the 3D context model. In my case, I've requested a context model to be sent in a 3ds Max format and FBX. The 3D context model and the proposed building are crucial to accurately preview each of the proposed views before sending the photographer and the surveyor on site. This precautionary measure and meticulous planning will help save time and money before sending the photographer and the surveyor on site. In 3ds Max, merge the context model with the proposed 3D building already placed according to its drawing coordinates on the site plan referred to earlier. Before merging files, ensure the system unit setup of this Max file is exactly the same as the incoming one to ensure the scale is correct. The system unit setup of this incoming file to be merged is in meters. To ensure this Max file is also in meters, simply click on the Customize button and choose the Unit Setup option. This metric unit scale here is for display purposes only and won't affect the scale of the objects. What affects the scale of objects in the scene is the System Unit Setup toggle parameters. Click on this toggle to check if it's also set to meters. As mentioned earlier, these are the parameters that will affect the physical scale of objects in this scene. As you can see, 1 unit is currently equal to 1 meter, which is consistent with the incoming file to be merged. If it wasn't, you could simply go into the meters unit and change it to any of the units displayed in the list and click OK. To merge the Max file with the context model and the proposed 3D building placed accurately in the scene, simply click on the Max button first. Go to Import and choose to merge. Select the relevant file to merge. In the Merge dialog, click All and OK to merge the entire list of objects. Next, click Z on your keyboard to zoom in closer to the selected objects in all 4 viewports. This is a purchased context model from Z Mapping website. And the proposed 3D building provided by the architect accurately placed in the scene according to the drawing coordinates referred to earlier. This drawing map is not directly related to this 3D context model site. However, it's being used as reference to show how the proposed camera views and the proposed building will be depicted on a similar document and drawings. To begin recreating one of the proposed views depicted in a drawing document, let's start by going to the Create panel and clicking on the Camera button. Next, click on the Physical Camera button. In the top viewport, click and drag the cursor point to create the first camera. Next, open the Modify panel and deselect the targeted function. This is to have the flexibility to move and rotate the camera without being constrained by its target point. When the camera target is enabled, it's always going to be constrained to its target, as you can see. Disable the targeted function and move the camera to the right slightly. To rotate the camera, right-click and choose the Rotate option. Rotate the camera 180 degrees so it's looking in the opposite direction. Next, right-click and choose to move the camera all the way back to where the building is. Rotate the camera slightly. Again, this camera is being created and placed in a 3D space according to one of the proposed views depicted in a drawing reference. Next, expand the viewport. Click on a perspective viewport. While the camera is still selected, press C on your keyboard to display the selected camera view. Next, click on a camera text in the viewport and choose to show save frames from the drop-down list. This option allows you to see the exact areas to be rendered. Select the proposed building seen in red in the distance and maximize the viewport. The entire 3D site is grouped. Click on a Group button and choose to open it. Select the tall blue building and open the display panel. The Hide Selected option is not available because we can't hide objects that are part of a group. Enable the Move toolbar. When this project was originally proposed in London, this tall building in blue didn't exist. To hide this building, click on the Group toolbar again and choose to detach it from the group. In the display panel, choose to Hide Selected. As mentioned earlier, this is the proposed building mass accurately placed manually in Max scene with a 3D context model using the coordinates and the drawing supplied by the architect. Extend the viewport. This is one of the many reasons it's utterly important to plan each of the proposed views meticulously ahead of time before turning up on the physical site to take photos in the survey points for verified views. This accurate and meticulous pre-planning methodology will also help architects and the planning authorities make better informed decisions about each of the proposed views with the proposed building and the context model in 3D. In terms of pricing, it also reduces the total production costs dramatically by preventing repeat visits to the physical site to take new photos and surveys. To adjust the camera view, click on the camera text and choose the option to select camera from the drop-down list. Open the Render Setup dialog. In a Common tab, to frame the camera view a bit better, let's change the width output size value to about 1200 pixels and the height output size value to about 932 pixels. As mentioned earlier, this is a starting point to get the camera views approved by the architects first and provide a sense of direction to the photographer before he or she goes on site. Minimize the Render Setup dialog and select the proposed 3D building mask. Maximize the camera viewport and go to the Create panel. Extend the viewport and go to the top viewport. It's worth mentioning that the 3D context model and the proposed building are close to the 0 point in 3ds Max. This is because camera light setting and the values are more accurate to work with in this location. In summary, even when your 3D context model and the proposed building are miles away from the 0 point, you need to manually move them closer to the 0 point in Max in order for camera light settings and the numerical values to work properly. The following step is to create the first chalk render to be later approved by the architect. To do so, open the Render Setup dialog and go to the Vray tab. Also, open the Material Editor. If Vray is not loaded, you can simply load it by clicking that button and choosing it from the list. Next, extend the Global Switches parameters and click on the default button a few times to turn it to expert mode and enable the override function. Before we do so, in the Material Editor dialog, select any material slot and rename it as Override. This material will be slightly white to emulate a simple chalk render. This basic chalk render is mainly to get this camera view signed off by the architect. Let's change this standard material to a Vray 1 by clicking on the standard button. In the Material Map Browser dialog, right-click on the Scene Materials tab and choose to filter selected objects. This will improve the display performance of materials in this dialog. Expand the Vray rollout parameters and choose the Vray material from the list. Once loaded, click on the Diffuse toggle. In the Material Map Browser dialog, expand the Maps rollout and choose the Follow procedural map from the list. Drag and drop the white color swatch into the black one and choose to copy it. Click and hold this color swatch to bring up its color selection dialog. Make the front color swatch to be slightly darker than the side one by moving up the whiteness arrow slightly. OK to close the dialog. Drag and drop the front color into the side one and choose to copy it. Click and hold on the side color swatch to bring up its dialog. Move down the whiteness arrow slightly to make the white color a bit brighter. OK to close the dialog. And make the front color swatch a bit darker to see a clear fall-off between the two colors. OK to close the dialog. Next, enable the Override Material function in the Render Setup Vray tab. Back in the Material Editor dialog, click on the Go to Parent button to go to the main parameters. Next, drag and drop the Override material into the Override toggle. Choose to instance it and OK to close the dialog. Also, it's worth mentioning that most camera height should be at eye level, which is around 1.6 meters from the ground or thereabouts. In the top viewport, pan and zoom close to the camera. In a camera viewport, select the camera by right-clicking and choosing to select camera, as previously done. We currently know that this building in red is on the ground level, so our camera needs to be around 1.6 meters above this ground. While the building is selected, hold on the Control key from your keyboard and select the camera in order to select both objects simultaneously. Next, click on the Isolate button to isolate both objects. Zoom in the front viewport. Select the building and open the Helper panel. Click on the Tape tool and enable the specified length. Next, type in 1.6 meters to set the length of the tape tool and click and drag it in the front viewport to create it. Adjust the tape tool so it sits at the base of the building where the ground level is. Click on the Select by Name toolbar to pick the tape target from its dialog. In the front viewport, move it down closer to the tape tool. Next, select the camera and move it up to be in line with the tip of the tape tool. This whole exercise is to ensure the camera is at average eye level of most people. Select the camera viewport and click on the Isolate button. Next, we are going to create the V-ray sunlight by clicking on the Light button and choosing V-ray from the list. Following that, click on the V-ray sun button and click and drag in the top viewport to create it. Once prompted with the V-ray sun environment map dialog message, click Yes to accept it. In the front viewport, zoom out, select and move up the sun head. This preliminary sun position is simply for the purpose of creating a draft chalk render to get this camera view signed off by the architects. Adjust the sun position until you are satisfied with the results. In a camera viewport, set the viewport to shaded by clicking on a realistic text and choosing shaded from the list. Next, in the Render Setup Command tab, lock the image aspect by clicking on this padlock button. Open the V-ray tab. Under Image Sampler Rollout Parameters, click on the Default button a few times until the expert mode appears. Under Type, choose the bucket. Under Bucket Image Sampler Rollout, set the max subdivisions to 100 to be consistent with the Universal Workflow settings. Set the noise threshold to 0.05 to speed up the draft render. Expand the global DMC parameters and change the setting display to advanced in order to see more options. This section here are for the maximum subdivisions, and this section here are for the minimum subdivisions, which should always be lower than the bucket image sampler. Set this noise threshold to 0.01 to speed up the rendering process. As mentioned earlier, the rendering settings are currently quite low in order to achieve fast renders. Next, open the GI tab. Change the primary engine to light cache. Change the parameters display to expert by clicking a few times on the default button. Enable the ambient occlusion. Type in the value of 350 mm to set it to millimeters. As you can see, 3ds Max automatically changed it even though the units display are in meters. Open the light cache parameters. Change the parameters display to expert by clicking a few times on the default button. For draft results, let's set the light cache subdivisions to 800. Let's go back to the global illumination parameters and change the primary engine to irradiance map for better results. Expand the irradiance map rollout parameters and change the current preset to low as a starting point. Change the parameters display to expert by clicking a few times on the default button. Also, enable the Show Direct Light option. This function allows users to preview the direct light and shadows during the pre-calculation process before rendering. Next, open the Settings tab and check some of its function by changing the default parameters to expert type and continue to check the remaining settings and tabs. Click on a camera text and choose to select camera. Click on the Max button and choose to save file as a verified view start. As you can see, the image aspect is locked. Open the V-ray tab and expand color mapping rollout. Change the color mapping tab to exponential by clicking and choosing it from the list. Also, change the default parameters to advanced by clicking multiple times on this button. and switch the color mapping mode to color mapping and gamma from the list. Enable the clamp output function. To ensure that gamma is also applied to the overall scene, click on the Customize toolbar and choose the Preferences option from the drop-down list. In the Gamma LUT tab, the overall settings and values should look similar to this one. The gamma value is set to 2.2 and the materials and colors are enabled. Click OK to close the dialog and save the scene again. Also, lock the camera view by clicking on this view padlock here. Even when other viewports are selected, the locked view will always be rendered because it's locked. Let's do a quick test render to see what the current scene is looking like. As you can see, the scene is looking a bit washed out and overexposed. Let's cancel it by clicking on this cancel button. To correct the overexposure, press A on your keyboard to bring up the environment effects dialog. In exposure control rollout settings, click and choose the viewer exposure control option from the drop-down list, and click on the render button to do another quick test render. The overall render is now looking more balanced and less overexposed. Next, open the material editor again and click on the diffuse toggle of the override material. Make colors a bit darker using some of the techniques covered earlier, and do another test render. To make the overall render even less exposed, increase the ISO value to 200 and do another quick test render. In the Render Setup dialog, under Vray Color Mapping Parameters, decrease the bright multiplier to 0.5 and do another test render. Next, open the Material Editor and go inside the Diffuse toggle again. Click on the Fall-Off toggle and open the Material Browser dialog. Scroll down and expand the Vray Rollout Parameters. Pick the Vray dirt from the list and click OK to close the dialog. In the Replace Map dialog, choose to keep all map as submap, check some of its default parameters and do another test render. As you can see, the overall render is now looking more appealing and contrasting, with the ambient occlusion affecting the direct and indirect lit areas of the diffuse toggle. Minimize some of the open dialogues and start repositioning the Vray sunlight to try some more appealing sun direction. Again, it's worth noting that these settings and the temporary position of the sun are for the sole purpose of signing off the proposed views before the photographer and the surveyor go on site. Once the photography and the survey are taken on site, the sun position and the camera will be later readjusted accordingly. Let's do another test render. Move down the sun slightly to have longer shadows and do another test render. External chalk renders often look more appealing with building outlines. To add them to the overall render, open the Material Editor dialog and go inside the Diffuse toggle until you reach the Fall-Off level. Click on the Fall-Off toggle and choose the Vray Edge Text Procedural Map from the list. Choose to keep all map as submap. As a first test, let's enable the Hidden Edges function and change its color swatch to black. Double-click on this material slot to preview the outlines. Click on the shaded text in Camera Viewport and choose to show edge faces from the list. Let's do another test render to see the effects of this procedural map. As you can see, the outline is also picking up the polygon faces. Let's cancel the render, disable the Hidden Edges function and do another test render. The outline effect is now looking a lot more appealing without the Hidden Edges option. Next, save the render by clicking on the Save button. Choose the Save As type to be a TIFF from the list. Click on the Setup button to bring up its dialog. Enable the 16-bit color option and the Store Alpha. Also, set the dots per inch to be 300 with no compression and OK to close the dialog. In Photoshop, open the preset TIFF file. To add a bit of contrast to the render, click on the Adjustment Layer button and choose the curves from the list. With your cursor, click on the upper part of the curve to add the first point and begin moving it upwards a bit. Also, add a second point on the lower part of the curve and move it downwards slightly. Begin adjusting both points to create a more contrasting image. To ensure we separate the building from the skies, click on the Channels tab, hold down the Control key and click on the Alpha Channel thumbnail to enable its selection. Next, click on the Select toolbar and choose to invert selection. Go back to the Layers tab. While the selection is still enabled, click on Adjustment Layers button and pick the Curves Adjustment layer from the list. Now we have the Curves Adjustment layer affecting the skies only. Adjust the curves to make the overall image more contrasting and interesting. To create a curves mask specific to the buildings, hold down the Control key and click on the Curves 2 thumbnail to enable its selection. Next, right-click on the Curves one and choose to disable the layer mask, followed by right-clicking and choosing to delete mask. Invert the selection and click on the Layer Mask button to create a new layer mask based on the selection. Now we have two separate curves with two different masks affecting two different parts of the image. To adjust, simply click on Adjustment Properties here and begin adjusting accordingly. Once you're happy with the chalk render, simply save it by going to the file and choosing to save as. Choose to save the file in Photoshop PSD file format first, in case you may need to revisit this chalk render. Next, choose to save it as a JPEG file format to be sent to the client. Set the quality to a maximum of 12 and OK to close the dialog. As mentioned earlier, most clients would often require between 5 to 20 verified views depending on what's required. So if you had that number of proposed views, you'd have had to go through the same process for each view to get them all pre-approved before sending the photographer and the surveyor on site. Once the chalk renders of the proposed views have been signed off by the client, you need to organize a day for the photographer to go on site. To create amazing CGIs for verified views, there's a company called vray.co.uk. I worked with them in the past, and they happen to be one of the best out there now. To find VReal, simply Google v-real. I will also leave their details in the links below. To organize a professional photographer, I often use Jeremy Young. Jeremy happens to be one of the best in the business for verified views photography, and has been working with all major companies in UK for almost 19 years. You can check his details here on LinkedIn and on his website. I will also leave his details in the links below. If you're based outside UK and need good contacts of photographers for verified views, please contact me directly. Before the photographer goes on site, he or she often uses an app called Sun Surveyor. This app enables users to preview and plan the direction of the sun and its shadows on any given day and time based on your geographical position. To find out more about this app, simply Google Sun Surveyor. Their website will quickly help you understand the app functionalities. Sun Surveyor also has a YouTube channel depicting how to quickly use our apps in less than 7 minutes. Once everything is organized, the photographer would then go on site with a tripod and all the necessary tools required by the planning authorities. This is one of Jeremy's equipment he was kind enough to provide me with when he went on site. The camera height is often set to about 1.6 meters. After a photo of each of the proposed views are taken, the photographer by law needs to mark up the location of the camera tripod as required by the planning authorities. Later on, the surveyor will need to use each of these marked locations to survey each of the proposed views as required by the planning authorities. The photographer also needs to provide you with an EXL document similar to this one, depicting all the necessary information for each of the proposed views. This information will be required to go along with your panning application and help you recreate each of the shots in 3D. While the photographer is on site, you can ask him or her to also take 360 HDRI shots of each of the proposed views to be later used for reflections and/or lighting. Most photographers now use cameras such as Insta360 ONE X to do this. However, feel free to use any other cameras you feel more comfortable with. Insta360 is very popular because you have amazing features such as video and still images all in HDRI, stabilizers and many more features. I will leave the link details about this camera. Once the photos of each of the proposed views are taken, the next step is to mark up the areas in each photo where you would ideally want the surveyor to take the survey points from. This photo is an example of one of the shots I've created for GMJ Design Limited. In this shot, I began marking up the areas I wanted each survey point to be taken from. The more points you have, the more accurate the camera matching will be in 3ds Max. The average number of survey points per shot is between 10 to 20 points per proposed view. To mark up the photo in Photoshop, simply enable the text tool, set the font size and begin typing in. To get the arrow pointing in a particular direction, simply enable the line tool and click on this option button. In Path option, enable the end arrowheads to get direction. Next, click and drag the arrow to create it. To create this circle, simply click on a marquee tool and choose elliptical shape from the list. Next, click and drag to create it. While the selection is still on, create a new layer by clicking on this button. Next, enable the Paint Bucket tool and click on a selection to fill it with a color. To change the color, simply switch the background color to red and click on a circle selection again to fill it with a red color instead. This is how I was able to create each of these points and text to mark up the whole photo. If you had 10 different photos with different views, you'd have had to repeat this action with every single one of them prior to handing them over to the surveyor to be surveyed. Some surveyors might end up surveying more points than the ones marked up on each photo due to practicalities and for better accuracy. If you happen to reside in the UK, there's a company called EDI Surveys, who happen to be one of the best in the business. They use some of the latest laser equipment for surveying. I will leave their details in the links below. Once the surveyor goes on site to take surveys, he or she will use some of the camera information previously provided by the photographer. On a surveyor's return, you should be provided with a series of photos depicting where each survey point was taken from for each of the proposed views. It's worth mentioning that this is just an example of what you would normally receive from a surveyor. In this close-up shot, the surveyor is depicting where the survey point number 10 was taken from. As mentioned earlier, some of these points might differ slightly from the initial markups provided because of practicalities and accuracy. Each of the survey points taken on site should be backed up by similar close-up shots like this. After double-checking each of the new close-up shots with survey points supplied by the surveyor, you may need to reposition the previously marked up survey points accordingly for each of the proposed views previously provided to the surveyor before going to the site. For instance, the survey point 05 is currently coinciding with the previously marked up point. If it wasn't, you'd have had to reposition it accordingly in the document, and repeat this action with every single point in proposed view. After the new survey points have been matched accordingly in Photoshop document, the following step is to recreate and match each survey point in 3D space for each proposed view. Before we do so, let's close most of these open documents. Prior to saving this file as a JPEG and loading 3ds Max, we need to recreate perspective lines in order to find the vanishing point and ensure the entire image is equally divided vertically. This process will make it easier to match the survey points and the camera in 3D. In a following step, we will take users through the amazing process of creating vanishing lines to center the photos accurately. Also, we will recreate the 3D camera and match the survey data in 3D using scripts. Furthermore, we also use X-references and dummy points to bring the survey data and cameras closer to the 0 point to create accurate renders. Finally, we will learn how to create AVR zeros, AVR 1s, AVR 2 and AVR 3. Click one of the links below to watch the rest of the course on my blog or Patreon page. Please don't forget to rate and like this course, and I hope to see you on my next one.